Let us look at Measurement System Analysis, MSA. Please refer to the highlighted part of the process control plan table explained in the previous chapter, from column number 24 to 31. All these control steps have to be controlled by an effective measurement system, with proper resources and trained personnel. Remember that, if you cannot measure, you cannot manage. Example. A major manufacturing company started getting calls from several of its customers reporting non-compliant materials received at their factories. The process was audited at the supplier end, and found that the parts were being produced out of spec. The operator was following the control plan or inspection plan, and using the assigned gauges for the inspection. The problem was that the gauge did not have adequate resolution to detect the non-conforming parts. An ineffective measurement system can allow bad parts to be accepted and good parts to be rejected, resulting in dissatisfied customers and excessive scrap. Measurement system analysis could have prevented the problem and assured that accurate useful data was being collected. An effective MSA process can help assure that the data being collected is accurate, and the system of collecting the data is appropriate to the process. Good reliable data can prevent wasted time, labor, and scrap in the manufacturing process. MSA is collection of data and analysis performed to evaluate a measurement system's capability, performance, and amount of uncertainty regarding the values measured. We should review the measurement data that is collected, the methods and tools used to collect and record the data. Our goal is to quantify the effectiveness of the measurement system, analyze the variation in the data, and determine likely source of variation. Data collected should be evaluated for bias, stability, and linearity. Let us look at MSA study. During an MSA activity, the amount of measurement uncertainty must be evaluated for each type of gauge or measurement tool, defined within the process control plans. Each tool should have the correct level of discrimination and resolution to obtain useful data. The process, the tools being used like gauges, fixtures, instruments, and the operators are evaluated for proper definition, accuracy, precision, repeatability, and reproducibility. MSA is defined as an experimental and mathematical method of determining the amount of variation that exists within a measurement process. Variation in the measurement process can directly contribute to our overall process variability. A measurement system has been described as a system of related measures that enables the quantification of particular characteristics. It can also include a collection of gauges, fixtures, software, and personnel required to validate a particular unit of measure, or make an assessment of the feature or characteristic being measured. The sources of variation in a measurement process can include the following: process, test method, specification, tolerances. Personnel, the operators, standard room staff, material lab staff, and their skill level, training. Tools or equipment, gauges, fixtures, test equipment used and their associated calibration systems. Items to be measured, the part or material samples measured, the sampling plan. Environmental factors, temperature, humidity. All of these possible sources of variation should be considered during measurement system analysis. Evaluation of a measurement system should include the use of specific quality tools to identify the most likely source of variation. Most MSA activities examine two primary sources of variation, the parts and the measurement of those parts. The sum of these two values represents the total variation in a measurement system. Management has to support to create required facilities to adhere to the MSA requirements. Typically the following resources are must for an organization: standards room, material testing laboratory, shop floor testing equipment, trained personnel, production of pre-launch samples, production trial feedback report, process capability study, pre-launch samples submission to customer, and customer feedback. First we look at standards room. This is the facility where all the gauges and instruments are maintained. Calibration of all the testing equipment is carried out at this facility. Also, critical equipment like profile projectors, roundness testers, CMM machine, master slip gauges, dial gauges, digital micrometers, digital height gauges, and other customized gauges are stored, calibrated, and maintained by standard room personnel. Next we look at material testing laboratory. This is the facility where the testing of incoming material to outgoing parts being carried out. Also, in-process checks mentioned in the control plan like hardness, tensile strength, microstructure, elasticity will be checked as per control plan frequency. Next we look at shop floor testing equipment. Shop floor testing equipment like vernier caliper, micrometers, go-no-go gauges, snap gauges, profile projector, hardness testers, special purpose gauges, and final inspection booths have to be provided in the manufacturing and assembly lines of the company. Next we look at trained personnel. Availability of competent staff, who understands the measurement system's requirements and its adherence. They are supposed to ensure all the above MSA or QMS requirements, with respect to measurement, and participate in NPD and face customer audits along with production and ME teams. MSA mean, collecting the data related to the measurement system, quantifying the variation in the measurement system, and taking a decision on the measurement system. Next we look at production of pre-launch samples.